Okay, so welcome to part 3 of making insulated steel roofs. The start of this video is a little out of sync as well, I filmed the first part, or what was the first part. The camera didn't record properly, so I'm having to sort of redo it. And that was just a bit about the spot welding and how that worked. And as you can see, I've got truck in to fix that. Which I will also be showing a video on some of that work, and the truck head and the engine head is here on the bench, waiting for the valves to be reseated, which is something that I've got to do probably tomorrow. But on with the main reason for this video. So this is about making the insulated steel roofs. So in the last videos we bent the sides over, so we cut them and then bent the sides over. So we've got all 4 sides bent over, and this is a spare one that I had, which I just missed some of the spot welding on. So on this corner here we haven't secured that, and all the spot welder does is it pinches it and runs a current through the steel, which causes it to bond together with a bit of pressure, and we end up with this here. So we end up with a weld. You stick a screwdriver in there and lever it, you will be able to get them to pop apart, because the way this works is you've got a big electrode here, which is like the anvil, and then you've got a smaller one above here, which is your main electrode, which is a bit thinner in diameter, and that's your heat point. And then it pushes down like that, and you get pressure applied on the handle, like that, which as the steel heats it forms a pressure joint. So unlike with the MIG welding, which we'll do later, it's not really an active process. All that it is that it heats it up, it melts some of the metal, and it forces them to interlock. So the bits of metal don't necessarily become one, they just interlock, so it's quite hard to pull them apart. So spot welds aren't the strongest welds. They work quite well on many things like body panels on cars, things like that, simply because you've got so many of them and they're quite quick. This is quite a small spot weld unit. That said, it pulls 20 amps normally, and it will pull up to sort of 50 amps at peak, so that's quite a lot of current. This handle anchors up like that, and then as you depress it, strings, but you've got to screw that one in, and that changes your tensioning on it. And what that does is it creates a point so that you can apply pressure, and these springs here just hook onto this handle, and I added those so that you don't have to use 3 hands, because you've also got to clamp that down, hold your piece of work in place, and then press this button here to make the weld. It takes a couple of seconds to actually make the weld. It takes more time to get the material into place. These are just some anvils that we had to take out. So that one there is the electrode point, which as you can see is almost gone. Actually mounts in up to about there, so there's not a lot left on that one. And that's the anvil that goes in to about there. And we just need to keep these clean, stop the zinc building up. So I will stop chatting with that and let you watch a bit of the spot welding. Once that's happened, I'll talk a little bit about the MIG welder over there. The bench was clear when I did it all, and how that works, what we use that for, and then you'll see how the roofs finish off. So the spot welding holds the corner tight like that, and then the MIG welding just goes down the seam to secure it and close up that gap so it can't be pulled apart. It makes a really strong bond, so you can't pull those that joint apart. So I'll get some spot welding done. caught in anything and make it quite rigid. So we're going to use a MIG welder for this, and the MIG welder I've got is this one down here. So it's a bit mucky, I've got to clean it up. It's just overspray of paint. We've got amperage up the top here, voltage down the bottom here, and they're controlled by these two. Voltage, amperage. The amperage relates to the feed rate, the speed at which the wire comes out of the gun, like that. The higher the amperage, the higher the feed rate, and that's simply because as the wire comes out, the quicker it comes out, the more consistently it's in contact with your work material. Therefore, the more amperage can flow. The ground clamp, or the earth, I've got strapped onto the table here, and that means everything touching the table can be welded. And as it's a MIG, this one's using a gas on 0.8mm wire. You can get 0.6, 0.8 and 1mm wire, and this will run all three. I find a 0.8 quite good for most jobs that I do, but it uses a gas which is over here, which is argon CO2 mix. So it's 5% CO2 to argon. CO2 is the reactive part, and that's what helps to make the weld, especially with steels. The argon is a shielding gas and prevents any particulates or any contaminants from getting into the weld and making weak spots. So I've set it up at 10 litres per minute flow, which is on this one, and then this one up here is how much is in the bottle. So the higher the flow rate, the cooler the weld will be, and that's done by the argon, which keeps it cool. The CO2 reacts with the steel as it's melted, and helps bind both bits of steel together. Else you can get particulates in between, which actually stop them binding. And what you find, especially if you try doing this without the gas, is that sometimes you can just crack the weld apart. It may look beefy, but it'll crack. So the voltage on the meter will control how deep this weld goes into the material. So the higher the voltage, the deeper it will travel and it will pull. The amperage controls the heat, basically, and you've got to balance the two for the material you're working on. So thicker steels will require a different balance. Doesn't work simply that you just turn one up. Generally, the thicker the steel, the higher the voltage, but the amperage doesn't necessarily increase proportionately. So you do have to sort of play around with it. If you ever think of taking up or trying MIG welding, I would spend the extra money, get a decent unit. The cheaper ones with the buttons instead for high and low, and then you can make high, low, medium. Basically, a 3 voltage points. This one is 16 to 22 volts, so it's got a lot more control. And you can see here, you can alter your amperage quite easily in points, and then you can do 19, 20, and that will change quite considerably the type of weld that you're getting. So I'll crack on, do a bit of welding, and you have a watch, see what happens, and we'll have a look at them once we're done. Right, just to show you the difference that the changing settings on the gas can make. This welder did just on the setting that I started with, which was about 10 litres per minute, and you can see here we've got a blowout of impurities here. That's what that black stain is. I just went through there, tweaked through there, and the weld is not particularly clean, so I have to clean that one up and redo some bits. Up. So then I jacked it up to about 12 litres per second, per minute, sorry, and then we done the other corner, and if you look here, we've got the white spray off all down the side and round. There's a tiny bit of bluing, but nothing, no real sort of black contaminant, so no sort of black marking really, all the way along, and the weld is much tidier. It's got a nice pooling, a nice carriage all the way along, and that's the only thing I changed between the two, is jacking up 2 more litres per minute. So it shows you what a difference that can make. It's quite interesting. So welding is generally all about fine tuning and to make things easier. A good welder can make a bad welder work for them. A bad welder, so someone who can't weld very well, will always struggle with a poor quality welder, but will be able to make up for it for one that allows a sort of better range of settings. Okay, so now we've got the welding finished. We've welded along the edges, so you can see here 1, 2, 3, 4. So that's all of them done and ready for clean up with a wire brush and having a protective spray, but that'll be next video. The reason that we weld the edges and don't just rely on the spot welds is don't want anything catching there, like ratchet straps and that, if you're moving hives around, getting caught. And also it really beefs up the structure. It makes them a lot stronger, and means that they'll last longer. And the reason I started doing this, having steel roofs and not worrying about the wooden substructure, is simply because larger steel, much more rigid than the sort of smaller gauge steel that they use to top hives when it's got a wooden substructure. Not a lot of cost difference, so these are actually come out with the insulation. So without the insulation, miles cheaper than a standard roof, and with the insulation, cheaper than a roof with a substructure, and you've got insulation in there, which is brilliant. So I mean, if you're folding steel anyway, the thinner gauge of steel you can fold just on the hive sometimes, push it down, and you can fold the corners rather than weld them. And all it's there for is protecting the wood. But hives over time, the older the hive, the wood tends to be the bit that's going to rot first. you know, you could have cedar roofs, they'll last longer, but they cost a lot more. So do that, put the insulation in, and they'll last a good while, and you get that really essential top insulation to the hive. So in the next video, I'll show you what we do in terms of cleaning them up, getting them sorted, painted, all that lot, and getting the insulation in, getting them stacked, and getting them gone. Alright, thank you very much. If you like the video, like it, subscribe, and then you'll see other videos as well. Alright.